The question is the probability of an anti-aircraft gun can hit is that it can hit an enemy plane at the first, second, and third shot are 0.6, 0.7, and 0.1. 0.60 respectively. The probability that the gun hits the plane is what we have to find. ठीक है, अब हम करते हैं क्वेश्चन को सॉल्व. लेट्स solve it. The probability of an anti-aircraft gun can hit the space an enemy plane at the first, second, and third shot. Okay, so if there is an enemy aircraft, it can be shot in the first or second or third shot. So we have to find out the probability. Let's call it the event of getting it shot at the first shot as event E2. We have to find out probability of E1 or E2 or E3. Like one of them, not two of them can happen simultaneously. So what is opposite of this event? No plane what is the event? Plane getting hit in the first or the second or the third. Plane not getting hit at first, second, or third shot. This is the opposite. This is the opposite of the given event. One of them getting hit. Yeah. So we will be able to find out the probability of event by doing this. So event 1 is not happening. 2 is also not happening. Or not happening. Is the solution statement clear? Is this clear, everyone?
Yes, sir.
Okay, great. So, and this E is basically probability of E1, E2, E3. Okay, and this is what we are calling at E as E. So this will become 1 minus probability of E1, E2, and E3 happening all the way same time. Not happening actually. There's a bar on them. So let's just first talk about probability of event. What is probability of event 1 was 0.6. So probability of even bar is like even one not happening is 0.4. Similarly, we'll write probability of even E2 not happening is 1 minus 0.7 is 0.3. Is that clear? How am I writing it so?
Yes, sir.
1 minus 0.1, 0.9. Okay. And now we also know one more thing. Plane getting shot at first or second or third is an independent event. So for independent events, we know that we can write it like this. We can just multiply the probabilities. Here, we have to find this. Sorry, let me type it like this. We have to find out this, right? So E1, E2, E3 whole conjugate या फिर single conjugate? There is a difference. Whole conjugate or single conjugate. Whole conjugate means even E2 and E3, even E2 and E3 happening simultaneously, and they should not. And whole conjugate means they even event means the plane getting shot at first, second, and third. Even let me write it and explain. See, even intersection E2 and E3. This means that the plane got shot at the first, at the second, and at the third, all three times. Okay. If I take a conjugate, whole conjugate now, it means that the plane didn't got shot all of the three times. But we are discussing just about the plane not getting hit at first, second, or third. It doesn't mean that all three times or not. It should not just get hit. Okay. For that, instead of writing whole conjugate, we should write we should write individuals individuals bar. No, event 1 should not happen, and event 2 should not happen, and event 3 should not happen. Okay, so this time we know the definition here. This can be written like probability of even bar, probability of E2 bar, probability of E3 bar. Okay, so we have the answers. So what was the numbers? 0.439, 0.4, 0.3, 0.9. 4 3s are 12, 12 9s are 108. 1, 2, 3. There are three digits after the point. So 1, 2, 3. Here will be a point. This is the probability of this. Now for the probability of event will be 1 minus what we have to find out is 1 minus that we have just calculated. 1 minus 0.108. So 82 909,918. 0.892 is our answer. Here is how we are going to find out because considering this case that one of them getting hit, no, that the gun hits the plane or not, then there will be multiple scenarios. Even hitted, even in E2 both happen, or even didn't happen, E2 happened, E3. There were little like there are multiple scenarios to consider. Instead of that, we'll just ignore all of them by writing this. Right?
Yes, sir.
Okay, then let's check the answer. 0.892. Yes, that's precisely correct. Now let's discuss one more example. Then we will move ahead and we'll discuss about the probability of three events happening simultaneously. Now this is interesting question. A and B A and B are two independent witnesses in a case. The probability that A will speak the truth is 3 by 4, not even 1. And that of B is 4 by 5. Okay, a quick question. Tell me, who is more truthful, A or B? In what percentage of cases they are likely to contradict each other in the same fact, in stating the same fact? Is my writing legible?
Yes, sir.
Now, please read the question and tell me who is more truthful, A or B?
B, sir.
B. 3 by 4 is 0.75. 4 by 5 is what? 0.80. So B has 80% of chances of speaking truth. So B is more truth. Yes, correct answer. Okay. So let's when they will contradict, when one will speak the truth and another will lie. Yes, that's when only. Yes. So let us consider the event of A saying the truth as A. Or let us say it event even. Event even represents A speaking the truth. Event E2 represents B speak the truth. And even bar represents A lying. And E2 bar represents B lying. Now the truth is one. If they say that they speak true, then they will not contradict both of them. So even and E2 are not going to happen simultaneously in case of a contradiction, right? So for contradiction, even maybe that A speaks the truth and and B speak and B speaks the B is lying. So this may happen, right? Or when I'm writing or union, or even may be speaking truth and E2 must be saying the truth. Even must be lying, like A person is lying and B person is saying the truth. It's crosswise, na? When A speaks the truth and B lies, then only there is a contradiction. When B speaks the truth and A lies, then there is a contradiction, right? So that's one case. Okay. And one more scenario can be there. Can you guess it? When both of those two persons can lie. When both of those, like when A speaks the truth and B speaks the truth, they cannot contradict because हमें we have to discuss the likely cases when they are contradicting in stating the same fact. When they both are speaking the truth, then they will not contradict. There's one more scenario. Can you guess it? And it's very interesting to think about it. Now, whether like it's for sure one can lie and another one can be saying the truth, then definitely they are going to contradict. Also, it may also happen that both of them are lying. If both of them are lying, then they will also contradict, right? Because they don't know what other person is going to lie about. They are two independent witnesses, na? So if they both will lie, even in E2 both will lie, there that is also a contingency. So what can happen more is even bar and E2 happening simultaneously. That how should I write it? And what is happening? Probability of even the A line and E2 is also lying. That may also happen. So this is one scenario where A is lying. When one is lying and another one's saying the truth. When one is lying, another one is saying the truth. When both of them are lying, and when both of them will speak the truth, then there will be no contradiction for sure, right? So let's try to write the probability of event contradiction. So probability of even, what is the probability of speaking the truth? Probability of even is A speaking the truth is 3 by 4. Its bar will be 1 by 4. 1 minus 3 by 4 is 1 by 4, na? Probability of E2 is given as 4 by 5. Probability of E2 bar is 1 minus 4 by 5, that is 1 by 5. Okay. When A is speaking the truth, 3 by 4, and when B is lying, so that is 1 by 5. Or when A is lying, 1 by 4 probability of that. And when B is seeing the truth, that's probability is 4 by 5. Okay, there is one more scenario in which both of them are lying. So even is lying 1 by 4 and B is also lying. So LCM is 20. The answer will be 3 plus 4, 7, and 7 plus 1. 3 into 1 plus 4 into 1 plus 1. 7 plus 1, 8 by 20 is the answer. Are there any questions?
No, sir.
Yes. Two people can contradict when both of them, if both of them are lying, or if one is speaking the truth, another one is lying. If these are the only two scenarios and conditions where I can think for in which two people will be lying and contradicting basically. Okay. So can we also think it like in a different way that there will be contradiction if and only if there is one person is lying, then only there can be a contradiction, right? So we can also solve this question in a different way. Let's try to do so. Uh, let's take a different page. The contradiction will only arise. Contradiction will only arise. Contradiction will only arise when we have to find the probability of contradiction. This will only arise when at least so instead of that, uh, let's call this event as E. Then it is also E. So probability of E can be found out by 1 minus probability of no one lying. Okay. So 1 minus probability of no one lying means that both of them are speaking truth. The chances of A speaking the truth were 3 by 4 and B also speaking the truth was 4 by 5. 4 cancels 4. 1 minus 3 by 5, which comes out as 2 by 5, and which is definitely not matching with our answer if I check. 8 by 20 is 4, 8 by 20 is 4 into 2, 4 into 5. Yes, yes, yes. It is matching with our answer. It is matching with our answer. So our answer can also be find it out in this way. Clear? Is that clear? It's a
Yes.
basic understanding that contradiction will only arise if one of the person, at least one of the person, will be lying. Okay. Now let's discuss about the probability of three events. This is the universal set. This is set A. This is set B. Let's increase the size. And this is set C. I want big circles so that we can write inside them. Okay, nice. So let's color on the intersecting part with this color. Nice. So this is set A, this is set B, this is set C. Now I would like all of you to tell me the like exactly what can I write with this. Let me give it a color also. This is red And I should give it a different color. Okay. Now this is fine, I guess. So now this red part is basically A set excluding B excluding C set. Like this is the A part, of course, but we are excluding the B. B is conjugate, and C is conjugate. Whatever is common with the B is conjugate and C is conjugate with A is this red part. Just try to imagine what is how we are writing. So let me write, and here this is B. A is conjugate, C is conjugate. Similarly, this is C with B is conjugate and A is conjugate. Now I'm writing about this black part. This is now this is um, actually this is having everything except set B. So A intersection, B intersection, no B conjugate and C, because B set is not here. A set is not here, B set is here, C set intersection is. A is here, okay. B is here or not? Yes, B is here. C is C is not getting intersected here. This is only the black part that I have written. And as you know, this is the most intersecting part. This is common in all three. This is just for you to understand, and it's really very important for you to understand. Now, I would like you to take a snapshot and please make it your wallpaper for 3 or 4 days at least. It will boost your understanding of sets. If you have any doubts in understanding in any particular elements representation, then you may ask. I give you 1 minute to observe and to understand that how every set part is represented in these forms. Please try to understand by yourself. Observe. If you have any doubts, you may ask after your observation period. Okay? Hello, hello. Is that okay?
Yes, sir.
Yeah, your 1 minute start now. Please carefully and mindfully observe. There are patterns everywhere. Please prompt and apprise when you're done.
Yes, sir.
Okay, great. Now I have a question then. Now tell me which color is representing only elements that are only in C set. Which color?
Orange.
Nice. Orange. Yes, nice. Now tell me which are those elements which are common in C and B set only.
Black.
Which black? This
The
black, right?
black on the right side.
Yes, sir. Right side, sir.
Okay. How many elements are there in only B? Which color?
Green.
Green. Olive.
And
Olive
what
green.
about, yes, what about the red, maroon?
Sir, red is in yes, sir.
Yes, red for elements that are only in A set,
Yes.
right? Yes. So if I have to calculate number of elements in only A, then how should I do it? If I have everything available, then how should I do it? I have to subtract. I will take all number of elements that are there in A set, and I'll subtract the elements which are common with B. Okay, so this and the let me write the next page. So this is these are three sets A, B, and C. है And we have to find out all the number of elements that are there in A only. Number of elements in A only. So what I'll do, I'll take all the number of elements that are there in A and we'll subtract number of elements that are common in A and B. Okay, so when we were taking whole A, okay, our this is cloud. Our circle was leaking the color outside. Let me make better circles. Yes, 1, 2, 3. A, B, and C. If we were discussing about all the number of elements in A, so these are the whole number of elements that are there in A. If I have subtracted A intersection B elements, so I have subtracted this. These elements are subtracted now. Okay. Now we have to subtract number of elements that are there common in A and C also. Okay. While doing so, I have subtracted this for sure, but I have subtracted this part once again. Now, I have subtracted it twice, which should not be happening. So we'll add it once. What is this? A intersection B intersection C. So these are the number of elements in A only. Is that clear, everyone?
Yes, sir.
Yes. This is very important for you to understand that if you have to find out the number of elements exactly in A, then this is what we need to do. Okay. How about number of elements in B only? Are we missing something? No, we are not missing something in this formula. Yes, number of elements in B only will be found by number of elements in B minus the common elements between B and C, the common elements between B and A plus, I have just written it similarly, na? So respecting, and symmetry is really great. Now, once you start understanding that there is symmetry in everything that is there in mathematics, then mathematics looks more predictable to you. Number of elements in C. So total elements minus common elements between B and C, common elements between A and C, plus number of elements A intersection B intersection C. Now let's find out the number of elements exactly in A, in B, and C. We'll add them all. Now we are adding all the three equations. So what will come is n of A plus n of B, number of elements in B, number of elements in C, minus 2 times of A intersection B, 1 and 2. 2 times n of A intersection B minus 2 times of B intersection C and 2 times A intersection C. Okay, nice. Plus 3 times and A intersection B intersection C. Is the formula clear? And here, and replace n with probability. This is applicable for probability as well, and number of elements in A only, that as well. Right? So and with the example of A only, we are able to understand about all three and about how we can find out the number of elements that are there exactly and only exclusively in A, B, C, right?
Yes, sir.
Okay. And of course, we have already talked about these formulas. And you can replace note why we are studying in probability. Note. You may replace n with p, okay? Anytime. Finding out the probability. So n of A union B union C is n of A plus number of elements B, number of elements C minus number of elements A union B, B union C, B intersection C, sorry, A intersection C plus A intersection B intersection C. You can also replace them with A, with probability. Okay, this is already known to us. Yes, is it so? Yes, is it so? So in this slide, we have talked about elements in A only, B only, C only, like a single. But what about elements in only two sets? So here we will discuss the same. Or we are running out of time. Sorry. We'll discuss it later then. Okay.
Yes, sir.
Yes, sir.